Now, let's explore an incredibly important real-world engineering problem. Look at example number 3 on your screen. Engineers are constructing a railway track using steel bars. Each individual bar has an initial length of exactly 2 meters. The linear expansivity of this steel, alpha, is 1.2 times 10 to the power of -5 per Kelvin. We are also told that the maximum daily variation in temperature, our delta T, is 40 degrees Celsius. Our objective is to calculate the minimum safety gap that must be left between these successive bars. Think about the physics here. When the hot sun hits the rail tracks, the steel bars will expand. If engineers don't leave a gap, the bars will push against each other and buckle, causing train derailments. So the safety gap must be equal to the maximum possible change in length, delta L, of a single steel bar. Let's bring back our trusted formula. Delta L equals the initial length multiplied by alpha multiplied by the change in temperature. Let's substitute our known parameters. We multiply our initial length of 2 meters by our linear expansivity constant 0.000012 and then multiply that by our temperature variation of 40. To make the math simple, let's multiply the whole numbers first. 2 times 40 gives us 80. Now we multiply 80 by 0.000012. When you calculate that, you get a final expansion of 0.00096 meters. Now look closely at our answer options on the right column. Notice that options B, C, and D are all given in millimeters, not meters. So we must convert our result by multiplying by 1000. 0.00096 multiplied by 1000 shifts the decimal point 3 spots to the right, giving us exactly 0.96 millimeters. Checking our choices, this matches option B perfectly. Engineers must leave a tiny expansion safety gap of 0.96 millimeters between each rail track bar.
Udimking Education Foundation. Building confidence, ending examination malpractice for a better tomorrow.
We are building a better tomorrow.
Join us in shaping futures through integrity and education.